right, folks, it's Bass Action back in action here. In this video, we are going to look at how to graph a cotangent function. And in the process of looking at the cotangent function, we're going to do a little review of the tangent because the graphs are very similar, but at the same time, very, very different. So let's start over here on the top on the left. Let's quick review of that unit circle where I've labeled the 4 quadrant angles in their ordered pairs. A little reminder that on our unit circle, the tangent is found by y over x dividing the y coordinate by the x coordinate. It's just like a slope. The cotangent, of course, is its reciprocal, so it'll be x over y. Now, because we're working with these fractions here, remember our tangent graph ends up with some undefined values. For example, at tangent pi over 2 and 3 pi over 2, it's undefined because we're doing 1 divided by 0 or a negative 1 divided by 0. Remember what that's going to do is that's going to give us these asymptotes. Anywhere it's undefined is going to create these asymptotes. And of course, those asymptotes will continue because it is periodic. Now, when we're thinking about the reciprocal, those asymptotes are going to move. They're going to be in a different place. So instead of the asymptotes occurring at pi over 2 and 3 pi over 2, they're now going to occur at the 0 and the pi. And of course, as those would continue. So over here, when we're looking at the cotangent graph is going to have an asymptote right on that y-axis, and then it'll have its next one at pi. So when we were graphing tangent, what we were thinking about is in terms of a phase shift, how did we move, for example, this asymptote? And I talked about the fact that you could move either one of these and that I usually focused on moving this one so that we could think about transforming an entire period of tangent. So on tangent, we thought about moving this asymptote at pi over 2. But on cotangent, we can actually move this asymptote right here that's right at 0 because from 0 to pi will give us a nice complete period. The other thing that I want you to notice is that a cotangent graph, this parent graph, looks like a tangent graph that's been reflected and shifted. And that is in fact true. And we will do some work with how we can connect these two graphs. But the key thing that I want you to be thinking about right now is that there's an asymptote here at the y-axis and that the parent graph looks like it is falling. Okay, so let's jump into an example, and then what we're going to find is that this is going to be very, very much like our tangent graph in that process. So things we can look at. We could look at this equation. We can look at a vertical translation. We can see that there's nothing being added or subtracted outside the cotangent function. So there is no vertical translation on this one. There is a stretch. We're looking right here for that 2. It has been stretched, and there is no reflection because if there was a reflection, it would be a negative in front of that. Now, to find that first asymptote, just like we did before, we can think about taking this entire expression, this x minus pi over 3, and what we're really thinking then is we're setting that equal to 0 because we're actually trying to move that first asymptote that we're looking at. We're wondering, how did that move? How did that get shifted? Now, this one's going to be pretty straightforward and pretty easy because there's not going to be a period change. There's only a phase shift, but we're going to go through this exercise of setting it equal to 0 just to see how it works. So solving this for the x, we're going to move that pi over 3, and sure enough, we're going to put our first asymptote at pi over 3. Now, I already mentioned that the period itself hasn't changed. We can see that because there isn't any multiplier in front of that x, but we can go ahead and remind ourselves that the parent period for cotangent is pi. So we would take pi, we would divide it by whatever coefficient was there, and thus our period for this cotangent graph will be pi, meaning the distance between each asymptote will be pi. Now, the distance between the key values, just like we did for tangent, we are going to only break up our periods into 2 pieces. It'll just make things a little easier for us. We're going to take our period over 2, or in this case, pi over 2. And then we're going to find the remaining key values. So our first asymptote starts at a pi over 3. And we want to add to that the pi over 2. That's the spacing between them. We're going to need to get some common denominators. So this is going to be a 3 over 3. This is going to be a 2 over 2 here. And then we're going to just start doing our arithmetic. So we're going to have our 2 pi plus our 3 pi. So our next key value is going to be a 5 pi over 6. From here, we can just keep adding this 3 pi over 6. So we're just going to keep adding that. So at a 5 pi over 6, we're going to keep going. We'll have an 8 pi over 6. We'll reduce, remember, in a little bit, 11 pi over 6. Add one more, 14 pi over 6. We're calculating all of these because we're going to graph 2 periods of our cotangent. If you want at this point, you could in fact find that domain, because our domain is going to be x such that x is not equal to, remember we want to pick an asymptote. Could be any asymptote you want. I like to do the first one that I found. So pi over 3. Then I'm going to add to that whatever my period is. So this will be the period. And that's going to be pi, and then it's going to repeat periodically. So then we'll put that k on there. Now, in terms of our graph, since our first asymptote is to the right of the y-axis, I'm just going to pick a point for that. One out to the far right there. I'm going to do all my dividing up like I've always done. And then since this is a cotangent graph, I know this first point is going to be an asymptote. Then every other one will become an asymptote. So we can go ahead and fill those in. Then we're going to go ahead and we can fill in our key values. So we'll have our nice pi over 3, 5 pi over 6, reduce the 8 pi over 6 to a 4 pi over 3, 11 pi over 6, and reduce the 14 pi over 6 to a 7 pi over 3. And what you should be able to see is that the distance between the asymptotes should be a period. So it is. In fact, this distance is a 3 pi over 3, which is pi, so we're good. Now, to go ahead and sketch this in, since there was no vertical translation, but there was a vertical stretch, we're going to imagine halfway between each of those points. We want to go up 2, and we're going to go down 2, because remember, it should look like a falling or a reflected tangent graph. So that helps us kind of sketch these in. And then remember, it has the feel of a cubic, but it's not a cubic because it has to approach the asymptotes. So I often kind of do these in these 2 little pieces like this. And there we go. We've got our cotangent graph. In the next video, we're going to look at our phase shifts finally for our sine and our cosine, and in class we will combine all of these together.